Hello everyone. In this video, we will demystify what SSL and TSL actually are and why they matter in web development. Whether you are building APIs or a full stack app, SSL is something you can't ignore. SSL stands for Secure Sockets Layer. It was the original protocol for encrypting web communication. TLS, Transport Layer Security, is its modern replacement. Most people still call it as SSL, but under the hood, it is actually TLS. Either it's version 1.2 or 1.3. So why do we need SSL? Without SSL, our data between client and server is sent in plain text. That means anyone on the network, like a public Wi-Fi, can read or modify it. SSL or TLS solves three big problems. Confidentiality, that nobody can snoop your data. Integrity, nobody can tamper with it. Authentication, you know the server is legit. So let's break this down with a simple SSL handshake. Client, the browser or any app, connects to the server. Server sends a certificate and the client verifies this certificate against a certificate authority. Once this certificate is valid, client and server agree on an encryption key. Then they use this same key to encrypt data for their communications. So what is this certificate? A certificate is like an ID card for your website. It contains a public key, a domain name, expiration dates, and a CS signature. Let's take a look at an actual certificate. If you go to any website, you will see this icon on the top that looks like a log. That means the certificate that this domain provides is a valid one. You can view more details by clicking on this. So it says connection is secure. That means it is using a valid certificate. So you can look at more information, and here you can look at the certificate itself. A certificate will contain a common name. It also has alternate names like this. It could be co.in without a www, multiple websites for same domain name. It also has a validity. So this is valid until 2nd July next year. And this is issued by DigiCert. There are many CAs that validate your certificate. Now let's explore the foundations. The public and private keys, how encryption works, and how to generate keys using OpenSSL. What are public and private keys? SSL encryption relies on asymmetric cryptography. In this, we will have two keys. A private key, which must be kept secret always, and a public key, which can be shared with anyone. When you encrypt the data, you can encrypt this using any of the keys, either private key or public key, and that data can only be decrypted using the other. Why should developers need to understand these basics? If you are working on any secure APIs or HTTPS endpoints, or you are issuing JWTs, then this foundation knowledge is very important. We will walk through generating keys, encrypting data, and understanding how this really works using OpenSSL tool. Let's start by generating a private key. We can use a tool called OpenSSL. Generate private key. We need to specify the algorithm. We'll use RSA. And what is the out file name? Private.key. This generates a private key. Let's take a look how it looks like. This is how a private key looks like. Once we have a private key, we can next create a public key from the private key. OpenSSL command. We are saying pub out. That means we are creating a public key. And input file is our existing private.key. And out key, the file name is public.key. So this will generate a public key. This is our public key looks like. This public key is created out of a private key. Now let's create text file and let's try to encrypt that file. This is a secret message. We will write this to a file called message.txt. This is the file that we created with a simple text. Now we will encrypt this file using the public key. For that we will use a tool called pkeyutl under OpenSSL. And the command is encrypt. And we will provide the public key. We are using OpenSSL tool and the command pkeyutl and the function encrypt, and we are passing in the public key. In key is public.key and input file is our message.txt and our output file would be message.enc, encrypted file. So this created an encrypted file. This is a binary format file, so you cannot really open and see it. It looks like this, a binary format. So we have encrypted the file and this cannot be read by anyone else unless they have a private key. So we do have a private key. Let's now decrypt it. We can use a decrypt function. And in key is private key. We are using private key to decrypt it. And input file is message.enc. And output file is message-decrypted.txt. So we are decrypting the file back to a text file. This is the decrypted file and it shows exactly like the original message. In summary, we understood what is TLS and how the certificates work and how do we create private and public keys using OpenSSL. In the next video, we will see how to create SSL certificates.